On. Welcome to this problem where we are going to dive into count the number of fair pairs. So basically in this problem you receive as input an array of integer and you are supposed to find out what is the list of fair pair. And what is a fair pair? A fair pair is actually a pair where the sum of the two elements of the pair fall in between the lower and the upper value that you also receive as input. So if you receive this as input, one valid fair pair is actually 0, 3, because 0 and the 3, they actually have a sum of 4, and then 4 fall in between 3 and 6. And the goal of this problem is to find out what is the total amount of fair pair we have in the given array, the input array. So for us to solve this, we are going to first sort our array. First thing we are going to do is to sort our array. Now after sorting your array, you have two options. You can take one element and have another loop that is going to, you can say, okay, I want to find all the pair having this as the first element, and you can take this and loop to the end, and for each of the element you check if the other pair that you are looking for fall in between the sum of the element with this, and the other one you're looking for fall in between the lower and the upper. But the issue is that if you do that, if you approach it that way, you are going to have a time limit. Another straightforward approach will be to use binary search, since the array is already sorted. Since the array is sorted, what you can do is that, okay, let's say I'm taking this pair. I want to take all of the elements having the pair 0. So I'm looking for the second element. So to find the second element, let's say we want the sum of 0 and the second element to be at least 3, right? So for us to find the second element, what we should search for is actually the lower minus the element that we took already, which is actually 3. So the first thing we are going to do is to find in our array the index of the element, or the first element, greater or equal to this guy, which is actually the lower minus the index that we just took, or the value at the index if you prefer. So by computing this, we already have the first element of our range of elements that can match with this guy. Now how do we get the second one? It should be less or equal. So it should be less or equal to 6 minus 0. How do we find less or equal? Actually, there is no direct formula for less or equal, but you can directly search for strictly greater and you take the element minus 1. Because if you are searching for strictly greater, you are 100% sure that the element before strictly greater is actually less or equal to the element you were searching. So that being said, how will the implementation look like? We need to sort in that for us to being able to apply our binary search. Okay, so now that everything is sorted, I will need to have my answer. This is the guy I will return here, and then now I need the for loop. Size I plus plus, and for each of the element, what I need to do is I need to have a start index, which will be equal to we said the start index is actually the lower bound, because we want greater or equal. Lower bound of who? So for each of the element I'm taking, I want my first element for me is basically the smallest element of the pair. So I'm going to search in the array greater or equal to this one. So the first element is actually num.begin plus I plus 1, because I want to search from, if I'm taking this, I want to search from the next till the end, right? And who is the n? The n is actually nums.n. I'm searching for which element? We agree that we are searching for element lower minus the element we took, which is actually equal to lower minus nums of I. Yeah, there we go. So this is actually an iterator to the first element of our range that is actually valid. And to have now the index, you just need to make minus num dot begin. Okay, there we go. So this is actually okay. And you may ask yourself, when we have the indexes, how do we do? Let's say you have this index, that means you are moving from year to year. You know that all combination of two elements of this element of this range will be actually be able to combine to this and have solution. And how do you compute? That means you are going to have the number of element of the range will actually give you the number of possible solution. And you do agree with me that, for instance, here, if you do here, we are going to see that 3 minus 0 gives you 3, which if you find, you are going to have this index which is going to be the start, and this one is going to be the end here. And then you can agree with me that all the solution 0, 4 is a valid, 0, 4 is a valid, 0, 5 is valid, and those are the elements here, 0, 3, 0, 4, 0, 5. Here you have 3, 4, 5 because they are actually talking about indexes here. Me, I'm talking about value, so that's why you have the differences, but that's the idea. Now for the second one, the n index, we said is going to be upper bound, because the upper bound is strictly greater. We are moving from num.begin plus 1, same num.end, now it's upper minus begin minus 1. Yeah, so at the end of this we have the start and the end. We just need to make ans plus equal to start index minus end index minus start index plus 1. Let us run. Perfect, working. Let us submit. Yeah, we can see that everything is green. So the interesting part of this was for me to be able to use the lower bound and the upper bound accordingly in order for you to find the appropriate range, and after compute just the length of the range. So if you are able to do that, that means, yeah, you have learned a lot of things from this problem. Hope to see you tomorrow for a new problem. Keep learning. See you. Ciao.